I'll try to drive the 4 kinematics equations using algebra. If you remember in the previous video, we derived those kinematics equations using calculus-based physics. But that one might be too much for you, especially Form 1s. But you can still drive those formulas using algebra expressions. And this is what we're going to do in this video. I'm Sam Lenga, your physics teacher. So today, we'll start by writing the graph of velocity. This side we'll put time. Okay, of course we know time is measured in seconds and velocity is measured in meters per second squared. So we are going to assume that this particle is moving from this point with the initial velocity. Then it accelerates uniformly. It accelerates uniformly to that point, okay, which we will label it as a final velocity, like that. All right. So using mathematics reasoning, we know that when you are trying to find the slope of this graph or the slope of this curve, you have a formula of gradient. For example, gradient of this slope can be calculated by y2 minus y1 over x2 minus x1. So what does this mean? It means that y2 will be the highest or maximum in the y-axis. If it was mathematics, this can be our y-axis and this can be x-axis. So the highest value in the y-axis, that will be our y2, and the lowest value in the y-axis will be our y1. Okay, then the highest value in the x-axis will be our x2, and the lowest value in the x-axis will be our x1. All right, so now that's how we calculate the gradient. But what does this gradient in mathematics means in physics? What does it mean in the physical world? So in the physical world, the gradient of these two parameters, velocity and time, is simply the acceleration. Because remember, the definition of acceleration is said it's a rate change. The rate change in the what? The rate change in the velocity, okay, with time. So since we have rate change, the change in velocity, that's what we are calling what? Acceleration, or the slope. So what does it mean? So in simple terms, the gradient that you find in mathematics, in physics, represents acceleration. And we know the symbol of acceleration. So we are going to replace. So where there is y2, we'll put our velocity, our final velocity that we have. Where there is y1, is the lowest value in our velocity column is v0. So final velocity minus v0, our lowest value. Then x value now we are having our time here. So we are going to replace. So we are going to put time there. Then minus time prime. Okay, so we know that means that then acceleration shall be v minus v0. Then when you just subtract the time, you still just have time. Okay, then you solve for velocity. So 1 times everything that is here, this times that, will still just give us v minus v0 is equal to, then this times that, it will just give us at. Okay, so we'll make v naught cross the equal sign this side, then it's going to become positive. So v naught plus at, and this is the first equation that we use. Some books, they leave it up to here, there's no problem as well. Some books, they will drive up to this point, there's no problem, it's the same expression. Okay, so you find others writing that expression as v is equal to u plus at. Where there is v naught, they replace with the v naught replaced with u. It's the same thing, we'll meet still. Okay, so this is our first equation that we've derived. Oops, I'll change that. So the second equation comes from by us calculating the area of the under the velocity time graph. Okay, so now when we find the area of a velocity time graph, what does this area represent? Okay, so in physics, when you calculate area under the time graph, it means that is our displacement, or rather distance. So let's do that. Let's calculate the total area of this one. For us in physics, we are solving for displacement. So we'll cut that because I'm seeing two shapes there. Okay, so we have that shape. We also have a right angled triangle. So we know that this part part A, which is it resembles the rectangle, and we know how we find the area of a rectangle. We know that the area of the rectangle is just v naught times our length here. It's what? It's time. So we'll multiply by time. Okay, then since it's a total area, we are going to add the area of shape B. Okay, so now how do we do that? We know that the area of a right angle triangle is calculated by half times BH. Okay, now let's analyze using our graph that we have, velocity time graph. So our base is actually from this point to this point there. Okay, so what do we have there? We just have these symbols, so we'll use these symbols that we have there. Okay, so our area is just half, then v minus v naught, okay, times then our height in this velocity time graph is just this point to that point. So, and what do we have? We have time, so we multiply by time that side. So times time. Now remember, we have this expression that is here. Okay, when we are solving here, we have this expression here, which I want to highlight it, this expression that is here. Okay, so we are going to replace where there is v minus v naught, we are going to replace it with that. So then half, then at times t. Okay, so when you multiply t times t, you are going to get a times t squared. Now remember, we are finding the total area. Okay, so what's the total area there? So we are going to add with that of A, that of shape A and shape B, which is right here now. So we add. So remember, area in physics, under time graph, it means displacement. So it's v naught plus half, then at squared Let me correct that. Okay, and we know we've seen this formula before, and this is our second formula that we've derived. Okay, other versions of these expressions, it is also written as ut plus half at squared. This is the same formula that we have. Okay, so the third equation comes from the definition of velocity. And what is velocity? We know that velocity is the rate change of displacement with time. That's how we define it. So we can say average velocity. Okay, average velocity is just the change in what? In displacement with what? With time, or change in time. Okay, so what do we do next? Then we will try to make our displacement as a subject to the formula. So we do cross multiplication here. Okay, so we know that would 1 times change in x, it will just be change in x is equal to, then we are going to have average velocity. Okay, going to have average velocity times change in what? In time. So now we have that that expression. Okay, so what do we do when we are solving for average? Okay, we know that if you are solving for average, if you have 3 items or 3 measurements, for example, you had 3 measurements. You have measurement 1, which is just, or I mean, let's use 2. You have 2 measurements, for example. You say the first one is 11.2 and the second one is 12.2 centimeters, and you want to find the average of this. So the average of that will be, you add the two things. Okay, it's 11.2 plus 12.2, okay, over 2, because they are 2. Okay, so that's how you find average of the thing. Now here we are saying average velocity. We are saying average velocity. Okay, so how are we going to find average velocity? So if we go back to our velocity time graph, we have this velocity, the initial conditions, and we have the final velocity. So for us to find the average of these velocities that are here, okay, we are going to do what? We are going to add them. Okay, so we are going to say where there is average velocity, we'll say v is equal to v plus v over 2. So we are going to replace this expression here right there. Okay, so what do we do now? So let me write that now, the new expression. So it is going to be v naught plus v over 2 multiplied by change in time. Yes, this looks common. You think you've seen this equation before. So that's how this equation is derived using algebra expressions. So that's our equation 3. If you want, you can express this equation in this form. We don't care when you do that. So it will be that, okay, v naught, you can put, where there's v naught, you can put u plus final velocity over 2 times time. This will still be the same. Expression. All right, equation 4, we are going to derive it using they already exist in expressions. So we use this expression number 3, or equation number 3, which we've derived. Then we are also going to solve for time from this expression. So for example, let's pick this expression right here. When we are driving the first equation, we'll pick this one, which is here. Let's pick this expression here. So what does it say? It says acceleration is equal to final velocity minus initial velocity over time. Okay, so we are going to solve for time. So what does that mean? So time it's going to be at is equal to v minus v naught. So I want to remain with time, so both sides I will divide by acceleration, so that goes. So time is just v naught, v minus v naught over a. Okay, so what do I do with this expression? So now I'm going to lift this expression and go and replace it right there. So the equation will look like this, that v naught plus v over 2. Then this side we are going to have v minus v naught, then over a. Then what do we do? So we are going to distribute this across there, and this as well as will also go like that. Okay, so if we do that, so x is equal to, so we are going to v naught times v, we are going to have v naught v. Okay, then v naught times v naught, we are going to have negative v naught squared. Okay, then come here, then v times v is just v squared, then v times that v naught, we're going to have negative v and v naught. Okay, then 2 times a here on the denominator, we are going to have 2a. All right, so then x, so the next thing is that we are going to group this numerator on the like terms. So we are going to group like terms there. So if you've noticed, we have this set and that set. So if you group them, definitely we are going to have a 0 there. Okay, so what do we have? So we are only going to remain with negative v naught squared plus v squared over 2a. All right, so what do? We are now going to make this as a subject of the formula. So remember, we are going to do cross multiplication here. So 2a times ax, we are going to have 2ax. Negative v squared plus v squared times 1, we are going to have the entire this. Okay, so let's now write. So negative v naught squared is plus v squared is equal to 2a change in x. Okay, so now we are going to make v as a subject of the formula. Okay, so it means that this will close here and it will become a positive. So v squared is equal to v naught squared plus 2a change in x. Wow, I think you've seen this equation before, or that equation which we are given for those who are doing grade 10. This is how it can be derived using these algebra principles. So this same equation can be also written in this version. So v squared is u squared plus 2 a x. This is just the same thing. And that's how you can drive these equations. Thank you. Subscribe to my YouTube channel. And when you watch a video, please comment to indicate that you've watched.